In 1984, astronomers were scanning a quiet, unremarkable patch of sky in the constellation Libra. Nothing about what they found looked special. Just a faint, dim star, invisible to the naked eye, sitting about 190 light-years from Earth. They gave it a boring catalog number, HD 140283. It sat in databases for years, ignored. One dot among the billions of stars we've cataloged and ultimately forgotten about. Then, decades later, someone finally asked the one question nobody had bothered to answer. How old is this thing? Here's how you actually age a star, because you obviously can't just ask it. Scientists read its chemistry, almost like reading rings inside a tree. Right after the Big Bang, the universe only contained two elements, hydrogen and helium. Nothing else existed yet. Every other element, iron, carbon, oxygen, even the gold in your jewelry, was cooked inside stars and only scattered into space when those stars exploded and died. So, the very first stars ever formed are made almost entirely of hydrogen and helium, the raw, primitive leftovers of the early universe before anything had exploded to season it with heavier elements. When scientists finally analyzed HD 140283, they found almost none of those heavier elements, which meant this wasn't just an old star. This was one of the very first stars to ever ignite. Chapter 2. The Number That Broke Physics. In 2013, a team ran the full calculation. The result, 14.5 billion years old. Here's the problem. The age of the universe, the number printed in every textbook on the planet, is 13.8 billion years. Read those two numbers again. The star, 14.5 billion. The universe it's sitting inside of, 13.8 billion. This star came out 700 million years older than its own container. Imagine finding your grandmother's birth certificate, and it says she was born 700 years before her own great-great-grandmother. It's not just a strange coincidence. It breaks the entire logical order of time. For a brief moment, scientists quietly wondered something enormous. Is the Big Bang Theory, the single foundation holding up all of modern physics, actually wrong, or at least incomplete? Naturally, nobody panicked publicly. They went back to double-check the numbers because measuring something 190 light-years away isn't like using a ruler. You can't touch it, you can't send a probe. Every measurement carries error bars. Using better satellite data from space telescopes designed to measure stellar distances with extreme precision, they recalculated. New number, 14.3 billion years, give or take about 800 million years, which means, taking the lowest number in that range, it just barely fits inside the age of the universe. By a margin of a few 100 million years. That's the entire buffer between "this makes sense" and "everything we know is wrong." Chapter 3. Older than it should be allowed to be. Even with the corrected number, here's the part that should still bother you. This star formed within the first 100 to 200 million years after the Big Bang. Picture the entire 13.8 billion year history of the universe compressed into a single 24-hour day. This star was born in the first 4 minutes. 4 minutes into a 24-hour day. And it's still alive. Tonight, while you're watching this. Most stars similar in size to our Sun live for about 10 billion years before they die out. This star has been burning for over 14 billion years. It hasn't just lived a long time. It's outlived its expected lifespan by 40%. By every rule we understand about how stars work, it should have died a very long time ago. It didn't. So, how has it survived this long? The answer comes down to size and temperature. Large, hot, bright stars burn through their fuel violently fast. Some of the biggest stars in the universe live only a few million years before collapsing. But small, cool stars are patient. They ration their fuel slowly, like a candle turned down to its lowest possible flame instead of burning bright and fast. H D140283 is one of these slow burners, quietly rationing the same fuel supply since almost the beginning of time itself. It was already burning when the first galaxies were still forming out of raw gas and dust. It was already ancient when the first supermassive black holes ignited at galactic centers. It was already old when our own galaxy was still a chaotic, colliding mess of young star clusters. Our sun didn't exist yet. Earth was billions of years from forming. Life, anywhere, in any form, did not exist yet. And this star was already burning. Watching the entire early history of everything unfold from a front-row seat, no other witness survived to describe. Chapter 4. It's Not Alone. Here's the part that makes this even stranger. HD 140283 isn't actually one of a kind, it's just the most famous example. Astronomers have quietly found a small handful of other impossible stars scattered through our galaxy. Stars whose calculated ages push right up against or even past the age of the universe itself. Most of these ancient stars live in a region called the galactic halo, a sparse, faint shell of old stars wrapped around the busier, younger disk of the Milky Way. Think of it as a fossil record hanging quietly in space, a graveyard of the earliest stars in our galaxy's history, orbiting slowly, rarely disturbed, sitting there since almost the beginning of everything. And every single time scientists study one of these ancient halo stars closely, they run into the exact same uncomfortable pattern. The math lands right at the edge of impossible, not comfortably younger than the universe, not safely inside the timeline, right at the edge, every time. Is that a coincidence? Or are these ancient fossil stars quietly telling us that our number for the age of the universe itself might be slightly off? Nobody knows for certain, and that uncertainty is exactly the point. Chapter 5. What this star is really telling us. Here's what actually matters about this star. It was never really about the star. It's about how much we still don't know. We like to believe we've got the universe figured out, a confident number for its age, printed in every textbook, a tidy theory for how it all began, taught to children as settled fact. But then one small, dim, unremarkable star, one point of light among an estimated 200 billion galaxies, each holding hundreds of billions of stars, comes along, and for a moment it makes the entire model wobble. That's the uncomfortable truth hiding underneath all of modern cosmology. We are not looking at the universe with perfect eyes. Every measurement, every calculation, every confident fact about space is our current best guess, built on instruments still being refined, corrected, and sometimes proven wrong, year after year. The Methuselah Star didn't break physics, but it came close enough to remind everyone, scientists included, that the universe is far stranger and far less understood than our confidence lets on. Right now, as you're watching this, that ancient star is still out there, still burning the same slow, patient flame it's been burning since before Earth existed, before the sun existed, before almost everything you have ever seen, touched, or known had even come into being. It has outlived exploding stars. It has outlived galaxies violently colliding and reshaping themselves across billions of years. It may very well outlive humanity and every civilization that comes after us. And it doesn't know any of this. It doesn't know it shouldn't exist. It doesn't know it's sitting at the edge of a paradox that quietly unsettles the people who study it. It just keeps burning. Quietly, patiently, at the very edge of what we understand. So, the next time you look up at the night sky, remember that some of that light left its star before time, as we currently understand it, had even properly begun. And ask yourself something uncomfortable. How much of what we confidently know about the universe is actually just our best guess, waiting to be proven wrong